Let's say if we have log base 3 of 4 plus log base 3 of x minus 1 is equal to 2. How do you solve this equation? And a big hint is this formula right over here, which tells you that if you have two logarithms added together and they have the same base, what you do is you just take the two things inside the parentheses and you multiply them together. So you can combine it into one logarithm. So how do we do this using this formula? Well, for starters, right, first of all, we notice that the two bases are the same, meaning that I can combine this into one logarithm. I can say that I can say this is going to be equal to log base 3 of 4 times x minus 1. And this is all going to be equal to 2, right? Because these two things have the same base, so what I do is I just take the things inside the exponents and multiply them, things inside the parentheses and multiply them together. So I'm just going to have 4 times x minus 1. Okay. Now, this is going to be log base 3 of 4x minus 4, right? Because you do the distributive property, right? So 4 times x is 4, 4 times negative 1 is negative 4. Now what you're going to do is you're just going to raise both sides to the power of 3. Now, in case you don't get this step, well, imagine that I have this equation, 3 is equal to 3. Well, obviously that's true, right? Now imagine if I raised 2 to the power of 3. So I basically exponentiated both sides. Notice how this equation is still equal, right? We haven't actually, even though we, raised, 2 to the power of 3, well, it's, the equation still remains true, right? If I raised both sides, if I raised, let's say, 4 on both sides to the power of 3, well, this equation still remains equal, right? So in this case, if we raise 3 to the power of log base 3 of this and 3 to the second power, since we raised everything, right, since we did it with 3 to both sides, well, this equation is still going to remain true, right? Now, logarithms and exponentiation are inverses of each other. So they're actually going to cancel out, okay? There's a logarithm property that states that if you, let's say you have log base a of b, and you raise it to the a power, you're just going to get b. So in this case, right, since we have 3 to the power of log base 3 of 4x minus 4, using this formula right over here, we're just going to end up with the thing inside the parentheses. So we're just going to be ending up with 4x minus 4, right, because these two things cancel out. They're inverses of each other. And this is going to be equal to 3 to the second power, which is 9. And this is going to be 13 is equal to 4x. And 4x is going to be equal to, x is going to be equal to 13 over 4. That's going to be our answer. Now, let's say if we have 3 to the power of x plus 1, and this is going to be equal to 5 to the 2x. How can we do this? Before learning logarithms, let's say if you were to solve, 2 to the 2x is equal to 4 to the, just 4. Well, in order to solve this problem, you can rewrite this as 2 to the 2x power is equal to 2 to the second power, right? Because 4 is equal to 2 to the second power, right? And then after that, because the bases of our exponents are the same, then you can set the exponents itself equal to each other, and you get that x is equal to 1. However, in this case right over here, we can't make the bases equal to each other, meaning that this has to involve logarithms. So what I'm going to do is I'm going to take log on both sides. So I'm going to take log on both sides. And if I just write log is the same thing as log base 10, okay? That's the same thing. But imagine if this 10 is invisible, basically. When you just write log, it's just like an invisible base 10 down there, okay? Now, the thing about logarithms is that you're able to bring down the exponent. So if you have log base, let's say c of, let's say, a to some power, b, this is going to be equal to b times log base c of a. Log base c of a. So basically, it's just the same thing, except you're able to bring the exponent down, right? So you get b times log base c of a, right? Just bring the exponent down. That's exactly what we're going to do in this case. We're just going to bring this x minus 1 down. So we have, x plus 1. And then this is going to be multiplied by log base 10 of 3, or just log of 3, right? And this is going to be equal to, we bring the 2 down, we bring the 2x down. So we're just going to get 2x times log base 10 of 5. Right? Because when you bring the 2x down, you're just going to be left with log base 5. When you bring the x plus 1 down, you're just going to be left with the log base 3, log base 10 of 3. Now what we're going to do is I'm just going to distribute this log base 3 inside this parentheses. So I'm going to get log base 10 of 3, x times log base 10 of 3 plus 1 times log base 10 of 3, which is just log of 3. This is going to be equal to 2x times, so just 2x log 5, okay? Now, in order to solve this is actually very similar to solving inverses of functions. What you're going to do is you're going to move all the x's to one side, and what you're going to do is you're going to move all the other log stuff to the other side. So what I'm going to do is I'm actually going to subtract 2x log 5 and then move it to the other side. So I'm going to get x log 3, log base 10 of 3, and then this is going to be minus 2x log 5 plus log of 3 is equal to 0, right? So I just moved the 2x log 5 to this side. And now what I'm going to do is I'm going to subtract log base 10 of 3 and move it to this side. So I'm going to get x log 3 minus 2x log 5. And then this is going to be equal to negative log 3. Okay, so notice all I did was I get the x's to one side. So in this case, I have the x's on one side, and I have the other log stuff without the x's on the other side. That's all I did. Now you can factor out an x. So I can rewrite this as x times log 3 minus 2 log of, sorry, I forgot to write down 5, but 2 log 5, okay? This is going to be equal to negative log 3, okay? This is why you have to move the x's to one side. It's so that you can factor out the x, and then after that, you can easily isolate x just by dividing both sides by just log 3 and 2 log 5, right? Just divide both sides by log 3 minus 2 log 5. Handwriting's getting a little sloppy, but our final answer should be x is equal to negative log of 3 divided by log 3 minus 2 log 5. Okay? That's going to be our answer. All right, now we have one more of this type of problem. Now, you can use the same way I showed you before. I'm just going to teach you another way. So if you have a to the m plus n power, this is going to be equal to a to the m times a to the n. So in this case, I can rewrite this right over here as 4 to the x times 4 to the first, or just 4, right? I could just kind of break it up into two kind of different things with the same base with different exponents. And now for this side, I can break it up into 7 to the 2x times 7 to the third. Okay? Now what I'm going to do, once again, I'm going to do the same thing I did before. So I'm going to divide both sides by 4 to the x. So the 4 to the x's cancel out, and I get 4 is equal to 7 to the 2x times 7 to the 3 over 4 to the x. Now what I'm going to do is I'm going to divide both sides by 7 to the third power. Okay, so I divide this side by 7 to the third power, and I just divide this side right over here by 7 to the third power. So this 7 to the third will cancel out, right? So I'll just be left with 7 to the 2x over 4 to the x is equal to 4 divided by 7 to the third power. And 7 to the third power is equal to, I'm pretty sure it's equal to, and 7 to the third power is equal to 343. So I'll just replace that there. Now, once again, I'm going to use basically the same exponent property, except this time I'm going to use another exponent property. If I have a to the m times n power, I can rewrite this as a to the m to the n power. So that's what I'm going to do for 7 to the 2x. I'm going to rewrite this as 7 to the 2 to the x power divided by 4 to the x. And this is all going to be equal to this. I'm just too lazy to rewrite it. All right, 7 to the 2 is equal to 49 to the x power divided by, and this is going to be 4 to the x power. Now, once again, another exponent property. So if you have a to the m divided by b to the m, this is going to be equal to a over b to the m power. So for example, if I have 3 to the 4th divided by 4 to the 4th, this is going to be equal to 3 over 4 to the 4th power. All right, so we're going to do the same thing here. we're going to say, okay, this is going to be equal to 49 over 4 to the x power, right? And this is all going to be equal to 4 over 343. Now, finally, last step to do is you just have to take log base 49 over 4 on both sides. Just take log base 49 over 4 on both sides. All right. Now, one thing to know is that if you have log base a of a, this is going to be equal to 1. Log base a of a is equal to 1. And the reason for that is because a to the first power gives you a, right? So in this case, I have 49 over 4, and then this is 49 over 4 right over here. Notice how it matches this form, right? So all of this is going to simplify out to be 1, and 1 times x is just x. So I get that x is equal to log base 49 over 4 of 4 divided by 343. Now this problem, or this way of solving it, involves a lot of exponent properties. So if you're good with exponents, I recommend this way.